Okay, irrational square roots. So before I talk about irrational square roots, let's talk about irrational numbers. Who remembers what irrational numbers are? Yes?
Oh, the number that you can't write as a fraction.
Correct. Numbers that you cannot write as a fraction. So I wrote it this way. Cannot express as A or B using integers. Okay. Okay, so it's a review. And of course, some of the examples of irrational, we talked about these irrational numbers. Pi, rad2, rad3, square root of negative square root of 10, and so forth, right? So, okay, if you like, you can write it down. Okay, so now what I want to talk about today is then irrational numbers that happens to be square roots. So we just had an example like square root of 2, square root of 3. Is square root of 4 an irrational square root? No. No. Okay. So it turns out square root of a perfect square, right, as a radicand, is not a irrational square root. Okay. So today I want to talk about then how we could simplify some of these irrational square roots. Okay. And so let's remember some of the rules that we learned from before, which were 2 rules about square roots. What do you guys remember about square root of AB? That's same as? Good. Square root of A times square root of B. What was the second rule that we learned last time? If this was something written as a quotient, square root of A over B, what's that equal to? Yes? Very good. So, of course, B can't be 0. So knowing these rules, turns out we can simplify these irrational square roots. Last time we simplified rational square roots, like square root of 4, we knew it was 2. But what if you have an irrational square root? Some of these irrational square roots, you could actually simplify these things. Okay, so, for example, something like this. Simplifying square roots, so where the radicand is not perfect square. Something like this. Square root of 216. So this is different now from last time because we're used to having the radicand as perfect squares. Now we have 216. So how are we going to simplify this irrational square roots? You have an idea, some of you? Okay, yeah, what do you think?
Well, you could like change it into like a factor tree, like the 2 times.
Yeah, you do a factor tree, right? And turns out, so let's just do a factor. You have an idea? What do you think? Maddie? Very good, very good. So if it contains a factor of a perfect square, right, we could simplify using the rule number 1. Okay. So how do we know whether it has a perfect square or not? Well, we do a factor tree. Okay, go ahead. Everybody do a factor tree. So when you do a factor tree for 216, we want to see how many perfect squares we have as a factor. Yeah, what'd you get?
I got 2 cubed times 3 cubed.
Okay. So I started off with 72 and 3. Did you have to do it that way? No, but at the end you should have the same factors. So yeah, I got the same. I got 3 factors of 2 and then 3 factors of 3. Yeah. So do you think it's best for me to write this as square root of 2 to the 3rd times square root of 3 to the 3rd? No. Why not? Yeah.
The square will cancel out.
Yeah. So how would you write it other than that way?
3 squared times 3 times 2 squared times 2.
Yeah, whole thing under square root, right? Very good. Yeah, so I want to like kind of pair them up because I know that square root of 2, right, square is going to cancel out with, square root of 3 squared is going to cancel out. So I simply get, what's square root of 2 squared, guys? 2. What's square root of 3 squared? 3. So I get 2 times square root of 2 times 3 times square root of 3. Is this the best way to write, or should I simplify further? Yeah, how? Kyle, what do you think? Yeah, 6 times square root of 6 is correct. Because isn't this, well, 2 times 3 is 6. What is square root of 2 times square root of 3, guys? Square root of 6. Isn't that simpler than writing as square root of 2 times square root of 3? So we're using that rule number 1 kind of backwards in this case, right? Just because none of these are perfect squares, right? 2 and 3. So it just simply becomes 6 square root of 6. This is a irrational number, isn't it? could also call that an irrational square root, because you know we have one of the factor as a irrational number, right? Irrational square root. So this is a little bit different than last time, right? Last time we had perfect squares, so we didn't get any of the square roots left. Now these are irrational numbers, so you're gonna get square roots. Okay. Do you guys get the idea? Does this make sense? Any question? Do you think you could do something like this? Yes? Okay. And let's try the next one. What if I have 3 times square root of 125? So how's this one going to change anything if I have 3 in front of it? Okay, go ahead, everybody try this. Give you time. So, first of all, did you all start off with factor tree for 125? What goes into 125? This is an obvious one.
5.
Yeah, 5 has to go in because it's with 5. So how many people got 5 times 3 factors of 5? That says, yeah, good. Judy, what did you write after this?
3 times square root of 5 squared.
Good. Can I forget about this 3 in front of it? No, then you can't just remember one. You can't forget about one of the factor of the number, because then it won't be the same. So then you write. I like how you pair them up this way. So because square root of 5 squared is what cost? 5. Huh?
5.
Yeah, it's 5. 5 squared, yeah, it's 25. But why do we write it this way? So we know that it's perfect square. So of course the answer class is 15 rad 5. How many people got 15 rad 5? Raise your hand. Okay. Any question? Are we good? I think most of you got this. Few people didn't. Go ahead and ask your group members. Okay. But let's go into the math. Are you done with this? Did you get it? Okay. Okay, then all of you. So what about the example 3? Give you something more interesting than previous one. Negative square root of 1920. How do we simplify this? Go ahead. Everybody try. Well, let me ask you this, by the way. What kind of, is this number positive or negative? And at the end, when you simplify a negative number, do you think it becomes negative or positive?
Negative.
It stays negative. It doesn't, right? A negative number doesn't become positive all of a sudden when you're simplifying, right? Does that make sense? Okay, go ahead, everybody try. Did you all start out with the factor tree? 1920. What's the easiest way to, yeah? Yeah, 10 and 19, no, 120, 192, right? 10 and 192, that's what I did. And you keep going, right? Until you reach your leaves, which are the, what kind of numbers are these? Leaves? Primes. You have to go all the way, you reach the prime. So, I keep going. Oh, it doesn't show. Anyway, so 4 is 2, 2, 2, 2, right? So how many 2s did you guys get? I got, 7, 1, 2, 3, 4, 5, 6, yeah, 7. How many 3s as a factor? 1s. How many 5s? So, do you think it's a good idea to pair them up? How many pairs of 2 are you going to get? 3, and then you have one more. So I'm going to write it this way. Is that okay? Is that okay? Instead of writing 2 to the 7th, I think you could kind of see easier how, it's easier to see how things cancel out. Can I forget about this negative? No, you cannot. Because then it will make the whole thing positive. Okay? How many people got it like this so far? Not all of you? Okay. How many people think they have the right answer?
I do.
Okay, Sierra, what'd you get? Negative 6? You sure we're multiplying? So it's going to be negative what? 8. Yeah, be careful. We're not adding, are we? We're all multiplying, so this is 2 times 2 times 2. And what about, Sierra, what about square root of 2 times square root of 3 times square root of 5? That's simply square root of 30. Okay. Correct. So you should get negative 8 square root of 30, right? Don't add these together. We're multiplying everything, right? These are all products. Any question? How many got this one? This question? Not all of you. Okay, I'm going to give you time to ask your neighbors, help your group. Okay, go ahead. I'll give you time. Make sure everyone has negative 8 rad 30. Okay, go ahead, help each other out. Yeah, so, whoops. Let me go back to that question. Okay, so yes, guys, listen. If you simplify a negative number, as you can see, it becomes negative when you simplify things, right? When you simplify a positive number, it is going to be positive. Okay, very simple. Now, let's switch your gear a little bit, and I'm going to ask you something like this on your homework tonight. I'm going to ask you, Square root of 27 is between which two integers? So hold on. Before you say the answer, say the answer. Before you say the answer, square root of 27. This is a real number, right? In other words, this number is on a number line, is it not? Now, where is this number located on a number line? Between which two integers? That's what it's asking, isn't it? So how do we do this? Yeah. Exactly. You find the closest to square root of a perfect square. That is between around 27. Do we know of any perfect square, of square root of a perfect square? Yeah. 5 square. Square root of 5 square, which is what?
25.
Yeah, what's square root of 25? 5. Right? So we know this is bigger than 5, because what's 5 really? 5 is same as square root of 25. And this is square root of 27, so 27 is a bit more larger than square root of 25. So I know it's got to be bigger than 5. What has to be, and between 5 and what? 6. What's 6 in terms of square root of 36? So you got it. See, this is what you write. You just write square root of 27 is between 5 and 6, because after all, what is 5 in terms of square root? Square root of 25. What is 6 in terms of square root? Square root of 36. By the way, on your homework, what kind of work do you think I would like to see for this kind of question? Yeah.
Like 20 the square root of 25.
Exactly. Something like this. 5 is square root of 25, 6 is square root of 25. And do you think like putting on a number line is helpful? Yeah? So there's 5, which is square root of 25. There's 6, square root of 36. Is square root of 27 closer to 5 or closer to 6? 5. Obviously it's closer to 5 because, 25 is closer to, 27 is closer to 25 than 36. Does this make sense?
Yes.
Any question? Do you see the kind of work that I want to see on your homework today?
Yes.
Okay, good. Yeah, I don't want you to just write down the answer, okay? I want to see whether you actually... Before I move on, I need to tell you this rule or fact about simplifying square roots. Turns out, when you're simplifying square roots, you may not have square roots on the denominator, because then you're not simplified, okay? So something like this. Like if I ask you to simplify square root of 2 over 3, we know from last time, what does the rule number 2 say? This is the same as square root of 2 over square root of 3, right? But Anais, we said that this isn't simplified, right? Why not, Anais?
Yeah, like have the square roots over each other.
No? Yes. You cannot have square roots on the denominator. As you can see, I have square root of 3 on the denominator, right? And so this isn't simplified. Okay, so what do we do? Oh, okay, so I want you to think about it as a group. Is there a way to get rid of the square root of 3 on the denominator? Go ahead, everybody think, okay, as a group? Go ahead. So, who thinks they know what to do for this one? 2, 3, 4. Yeah, you guys did it. Christine, what do you think?
You multiply 3, top and bottom.
Multiply by 3 or square root of 3?
Square root.
Square root of 3. Is that okay to do? Can I do this?
That's just 1. That's 1.
Yeah, this is just 1. So, when have we done something like this before? Where you have a fraction, you multiply top and bottom of the fraction by same number. When do we do this? When do we do this, guys? When you are trying to get a common denominator. In here, well, for this case, we don't want common denominator. Well, right? Because we're not adding, but we could do that later, but that's later. Anyway, the reason why we do that is because what happens when you multiply square root of 3 times square root of 3? You get simply 3. But what about my numerator? My numerator still remains square roots. Is that okay?
Yes.
Yeah, we don't mind numerator becoming square root of something. We just do not want the denominator to have any square roots. Does that make sense? Do you see what I'm doing here? So this is really 1. If you multiply a fraction by 1, the value of that fraction still remains the same. So we get what class? Square root of? What do we get on the numerator? Square root of 6 over 3, because that's square root of 3 squared. Isn't that right? Do you see how we could get rid of the square root? So then the answer is simply square root of 6 over 3. Right? They both have same value, except now we have simplified the square root. We don't have our denominator as a square root. Does that make sense? Any question? Yes? Okay, explain to your group members. I think some of you are still confused. Go ahead. So then if you got that previous example, try this one. Square root of 9 over 8. I put 2 stars on this. You'll see why in a minute. But go ahead. I guess, how do we simplify square root of 9 over 8? Go ahead, everybody try. I'll give you time. Nelly, what did you guys do here?
We put 3 over root 8.
Oh, okay. So simply, first of all, square root of 9 over square root of 8. So square root of 9, what is square root of 9? That's what I've done too. That's just 3. So then, after that, Savannah, what did you guys do? So now that this is square root of 3. Savannah, what should I do after that? Okay. I know that's square root of 9 is 3. So but I still have square root of 3 over what? Square root of 8. Right? So what do we do? Yeah, multiply top and bottom by square root of 8 over square root of 8, right? Question? Okay, we'll get there in a minute. Okay, so then what do we get, class? We get, doesn't it become what? 3 times square root of 8 over 8? We're done, aren't we?
No.
Oh, really? Why not? Malia, how come we're not done here? Hold on. Okay, some people are still talking. Guys, it's time to listen now. Go ahead. Yes, square root of 8, as we've done before, contains a factor of 4, doesn't it? So 8 is really, so we're not done here. Right? So that's why I put 2 stars. So then, when you simplify, we know that it's square root of 3 times square root of 4 times 2. What is square root of 4? 2. What's the answer? 6 rad 2 over 8. Then you're not done still. 6 rad 2 over 8. You're still not done. Why not? Raise your hand. Why not? Yes.
I just have a question.
Hold on. Why not? We'll get there in a minute. Yes.
6 over 8 can be simplified to 3 over 4.
Yes. 6 over 8 could be simplified as what?
Yeah.
0 over 4. Right? Yes.
What we did was we simplified rad 8
Good. Hold on a second. So,
to rad 2.
hold on to that thought. I'm going to show you actually, yes, that's actually a better way. I'm going to show you another way of doing this, which is easier. Anais, what's your question now?
How did you get 3 over rad 8?
Okay. Anais, what's square root of 9?
Oh.
Yeah, so square root of 9 is simply,
Simplified.
so yeah. Okay, but Cameron, what were you going to say? Hold on. Yeah. What did you guys do? You guys did it differently than this?
We simplified rad 8 into 2 rad 2.
That's right. You know, by the way, before we get there, could I do this? 2 and 4. Could I cancel them out? Doesn't 2 go into 2 and 2 go into 4? Why can I not cancel them out?
Because it's rad 2.
Say it again.
Because it's rad 2.
So, it's still 2.
No, but
You're right. Why?
it's like rad 2 is like some number multiplied by itself.
It's an irrational number. It's some decimal. It's not 2, is it? Does that make sense? It's one number between 1 and 2. Right? It's 1 point something, 2 something. So it goes on forever, right? So you cannot cancel this out. Please don't do that. Right, guys? You cannot cancel a radicand with a number outside. Yes? Are we good?
Yeah.
So what Cameron was saying was this though. Remember I told you to always simplify. So before you do anything, 9 over 8, we know it's 3 over square root of 8. Right, Anais?
Yeah.
Because not square root of 9 is 3. Now, what is square root of 8? Could we simplify this here first?
Yeah.
Don't we know what square root of 8 is?
Yeah.
Isn't it 2 times 2 times 2? Aaron, what's that come out to be?
2 rad 2.
Yeah, it's 2 rad 2. Right? Because it's square root of 4 times square root of 2. If you do that or in the very beginning, before you do anything, always simplify before you go ahead and do things.
That's what I did.
It's a lot easier because all you have to do then is what? Multiply top and bottom by
Rad 2.
square root of 2. Right? Then it will get rid of that square root of 2. You don't have to multiply by a big number like square root of 8. Does that make sense? So if you do that, it just becomes 3 times square root of 2 is square root of 2. 2 times square root of 2 times square root of 2, isn't that simply 2? Because it's square root of 2 squared, or square root of 4, right? So then you simply get 3 rad 2 over 4. You didn't have to simplify all these things just like before. If you simplified at the very beginning. Does that make sense? Which way do you guys like better? The second method or the first one? Second method? I think it's a lot better if you do the second method because, right, always simplify this square roots, right? If it, check and see if it contains any perfect squares in there, right? Because this simply becomes 3 over 2 rad 2. All you have to do is multiply typing by rad 2 because we just need to get rid of the square root of 2 on the denominator, right? Does that make sense? Yeah. Okay. Any question? May I move on? Yeah. All right. Then, what if they ask you to do this on your homework tonight? Simplify square root of 2 times square root of 5.
Easy.
This is one of the easier ones. We simply use rule number. There were only 2 of them. Rule number 1 backwards. What is square root of 2 times square root of 5, class? Square root of 10. That's it. Okay. So on your homework, it's going to ask you to do something like this, but it's very simple. Yeah. It's very simple. Any question?
I guess I asked which rule it was.
Okay.
Good check.
Okay. Any question? Are we good? Okay.